Hello all, welcome to this second workshop of this series, which I call Repeat, Repeat, and Repeat. In this workshop, we are going to learn how to utilize repetition to create different visuals. Repetition can be used in different ways. It can be linear, it can be circular. And one of the things we will do is to create a grid, and then we will manipulate each individual element in the grid. And let's get started. So let me start by sharing my screen right here. And again, most of the stuff we will be doing, it will be in the P5.js web editor. This is an example of something that we can create. Yesterday, we did something more horizontal, and this is a more complicated shape. And this actually is a specific pattern called Lisa drew that can really be many different variations of patterns. But that's what we will be doing today. First, I'm going to give it a name, workshop number 2, and let's see, I'll call it repetition. Again, this is just a complete new sketch, and we're gonna start. We're gonna start by reviewing what we did near the end of last workshop, which is a linear repetition. So in order to have any sort of repetition, we would need to use a loop, and in the specific case, we will use a for loop. Let I equals to 0. These are all the stuff we did yesterday, and I'll do 400, so it's all the way from 0 to 399, and I plus plus. So that's a for loop. And then with this I'm going to draw a circle with I as the x-axis and 200 as the y-axis and 50 as the diameter. That's what we get. One thing that's different today is I use I plus plus here. So because we do this so much, I equals to I plus 1, which increments I by 1. Because programmers do this so much, there's actually a shorthand, which is simply I plus plus. That does the exact same thing, but just easier to write. And that's where we get this repetition of circles. To further illustrate how repetitions or for loops work, I actually prepared a sketch to demonstrate that. Let me move this all the way over here. So for our for loop, essentially we are looking at 3 sections. The first section, let I equal to 1. I is what's called a variable. That's essentially, it's a name for, a name that you can choose whatever. It doesn't have to be I, but I is used as a convention. I believe it represents index. So that's why it's usually, start from 0 to a different number. And so the first section, which we were having here, let I equal to 0, that is to represent the initial state for this I. And the second part, I smaller than 400, that's sort of the end, or I mean, that usually define the end, or in another way, it essentially tells you under what condition should I continue, should this loop continue. And I equals to I plus 10. That's what happens after each iteration, after each time you run this loop. So this is what we have here. If I start with 1, I actually don't remember why I did 1. Maybe that was just easier to understand. Yeah, but over here, usually we start with 0, but over here, I think the smallest value that I put was 1. So um, I guess, yeah, I think I was using I probably as the diameter, and yeah, it doesn't make sense to have 0 as the diameter, I guess. So if I adjust to the I, let's say all the way from 1, we're starting from the center of the circle. As we increase, let's say if we start from 100, then the smallest circle is going to be 100, and every time the diameter is 10 pixels different. As we adjust the difference, so for instance, if I set this to 100, then the first circle, actually a little hard to do it exactly 100. Let's do this 100, yes. Then the smallest one is 100, then the next one is 200, and then the next one 300. And because 400 is no longer smaller than 400, that's why we only see 3 circles. And this is where you define the last one, the range. So in this case, I has to be smaller than 113. That's why there's only 1 circle. But if this is 244, then there's enough room for 2 circles. And yeah, so that's something you can play around and just help you understand how the for loops work. And that was for circles. There's also horizontal line. So let's say start from 1, that means start from all the way to the top. This is essentially adjust the end. This is the top. This is how much gap you have in between. Same thing for a vertical line, and you can turn this to on at the same time. And this, in a way, you already have some sort of grid with like adjustable sort of gap. And this is also a perfect example of what the kind of thing you can do with P5JS. So I'm teaching P5JS, but I'm also using P5JS to create a small tool to demonstrate this concept. And yeah, so yeah, there's a lot you can do, depending on, I mean, also like if you are making certain designs, you can also add this kind of toggles so that you can dynamically adjust certain values to whatever you need. So back to this, I hope that explains how the for loops works. Any questions about for loops? Oh, good. Okay. So now let's get back to the sketch we were working on yesterday. Actually, let's, the smallest change we can make is instead of using I as x, we can use it as the y coordinate. So now it goes vertical from top to bottom, and the next step is that we can add sine to the x coordinates, so that let me stop this for now, so that it moves left and right. So sine with I as input, and divided by any number. It really doesn't have to be the number I have, and maybe 100. And now we see a beautiful sine wave. And as we adjust this number, if the smaller the number, maybe it makes more sense. Maybe it's easier to understand if we do like times something. Yeah. So essentially, the larger the number, the faster the input is. And if the input changes too quickly, then the output will change very quickly as well. And 9, and if this is 1, that's what it looks like if it's 1, 2, 3, 4. so on and so forth. Okay, so that's what we had yesterday, more or less. And what if you want this to be circular? So in that case, we would want to add this sign also to the width. Sorry, also to the both to x-axis and also y-axis. So I'm going to do a 200 plus yeah. Essentially, it's like the same thing for both x and y. So what happens now is that the x coordinate and y coordinate changes at the same time. That's why we sort of see a straight line. However, if we change one of the value to cosine, that's when it starts to make a perfect circle. Again, there's like a little bit of math there, and yeah, when you use sine for one of the coordinate, cosine for the other coordinate, that's where you have a circle, perfect circle. And but if we play with the number, that's where we see that Lee Sedgwick pattern. So if I change that to 0, 2, it's really great that yesterday I already seen some of you sharing your work where you use this technique where it has this sort of infinite loop pattern. But as you change the number, you can see a lot of interesting patterns just by playing with sine and cosine. Like this and 2, yeah, just this the possibility is endless just by playing with all these numbers. That's all too small, looks like. Yeah, and you have a lot of interesting patterns. So there's a couple of different way we can a couple of things that we can do. One thing we can do is if we would like to make like a generative pattern, like it generates a different pattern every time we refresh, like right now, because we used all fixed values. If you press play, 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 it's always exactly the same. If that's a very specific design you like, perfect. However, sometimes you want the sketch to surprise you. You like to add a little bit more randomness or changes for each frame. For each time you refresh, we can do that by adding random. I'm going to save this one, repetition or repeated circles forming Lisa Drew. Yep. One, I'm going to just save, and I'm going to duplicate. Yeah. So what we can do is add a little bit of randomness, and the value we want to change is the value inside of the sign. Let's see what happens with add 2, add 3, add 4. That already changes the number. So one thing we can do is add random over here. And let's say we add random maybe 2. Yep. Now it changes sort of really, really quickly. Maybe I want a value from 1 to 2 or 1 to 5. Yeah, it's really up to you. And you see already that's like a lot of interesting thing that I didn't expect. Again, if you put your code inside of inside draw, it's going to keep going. It's going to run multiple frames per second. One thing we can do is to move the whole thing inside of setup. And that way it generates a fixed pattern every time you refresh. So Every time you refresh, it's going to use a new random value, and it's going to generate a new pattern. This, I think right now it looks a little bit too messy. We should be able to fix that. I think it's messy because the value is, yeah, let's see, 1, 2. Yeah, I believe that's because the value is like when you have a value that's kind of a little off, or is that because it might be because it's too small, or that's interesting. How come that random value? Anyway, what we can do is to make sure that value is integer. In order to do that, we can literally round it up by adding round before and after random. That's actually very interesting. Somehow the number, am I not putting it in the right spot? Because, yeah, because when I put a 5 here, it looks a lot more even. But when I use a random number, I see what's happening here. Okay, so actually I made a mistake here. The reason why it looks so random is because we are generating a random number for every circle. That means for every circle it's trying to draw, it's going to be at a random X value. We don't want that. We want a random value for the entire frame, meaning if there's offset, all the circles should be offsetted by the same value. So the random, I put random at the wrong spot. And that's actually a perfect opportunity to introduce how to create a new variable. We've already used variable inside a for loop, but you can also create variables outside for loop. Let's say I'll call this, let me stop this. I'll call this, I hope that didn't, yeah, call this offset. So it's just offset to adjust sort of the shape. So offset equals to, I'm going to copy this, paste it over here, or you can simply just rewrite this. Let offset equals to random 5, or maybe you can even do 10. So this offset can be anywhere from 0 to 10. And I'll add, instead of adding that random, I'll add offset here. Yeah. This time, every time you refresh, it should be going to, let me make this a little bigger now. Every time you refresh, it generates a different leaf pattern. Does that make any sense? Any questions? Yeah. And yeah, so that's what happened. So this is if you like to have some kind of pattern that every time, even though you wrote all the code yourself, but if you share this sketch with someone else, what they see and what you see are most likely different because it's always a random value that help generate this pattern. But this is also an example of how, even though we're using random, the end result doesn't really look random. It's pretty pretty uniformed and sort of pleasant looking. And let's also add color. Actually, before we add a color, let's add random to both X and Y. So instead of offset, I'm going to call it offset X. And additionally, I'm also going to add offset Y. And offset X equals to random 10, offset Y equals to random 10, even though they look exactly the same. But every time you call this function random 10, it's going to generate a new value for you. So offset X to add it to the X, and offset Y added to the Y position. Yeah, again, that's just a random number. And another place, one other way to make it random. So this is to add offset over there, but you can also add offset. Let me stop this. Maybe I'll just make this slightly smaller. I hope, are you still able to read the text if I make the window smaller? If I make, yeah, I hope that's fine. Let's can't run this. Yeah, just so that we can see the text in one line. Um, offset Y. So this time, instead of, I need to be careful um, with the parentheses. Instead of adding offset instead of sign, I want the offset to be a part of this 0.06. But now the changes, the offset 10 is too big. We only want to change 0.06 by like a small value. So let's say 0.3, maybe 0.04. Yeah. So because the number we are adjusting this time is this number, we are adding a value to 0.006. If we add value like 10, it's a very big change that, make it look pretty messy. And now this is a even more dynamic shape pattern that we're creating every time. And I'm going to, again, give it a good name, random. Okay. And when people say generative art, this is one example. So every time it generates a new pattern, a new shape. Yeah. Personally, I don't like the term generative art because I like to, this, I would say, because it's really very much depend on the function random. So in a way, it is generative. A lot of what I do, I try to have a little more control over how the end result looks like. So I very much think of it as something that I created instead of just generated, which feels like as if it just computer did the work and the artist didn't really do anything. But that's just my opinion. And all that also depends on how exactly you work with the sketch. I noticed there's some messages. Yes, great. Any questions so far before we move on? Oh, good. So far it's all static. It will be a lot more interesting when it starts moving, which we already did in a linear way yesterday. So I'm going to duplicate again. And in order for them to move, I want to move them to draw. And again, keep an eye on what you are cutting or copying, and make sure you don't mess up the setup and draw function. So setup start from here and end from there. And I don't want to accidentally delete the curly braces from setup. So I'm going to move here. Now just generate random one really, really quickly. And I can actually utilize this offset I already have, the offset I'm using. But this time, instead of random, what I can do is to, again, our good friend sine cosine, we can use that. So since we want this value change to be relatively small, again, I'm going to use this as a factor. So 0.03 times sine. And this can be frame count, and same thing for both X and Y. Yeah, for now, let's start with the same value. This is going to change fairly quickly, almost like the previous one. That's because frame count changes from 0 to 1 to 3. So the sign, also, the output is also going to change very quickly. So I'm going to divide this by 10. divide this maybe by 20. Now it's slightly that it's slower, but it's still pretty fast. So I'm going to add this. See how now it has like a very interesting motion. And this is actually what I like about this kind of about creative coding. Oftentimes the sketch really surprises you, and that really generates something that you do not expect. And just by playing with the numbers, you can see a lot of different patterns, different. Again, I think I prefer slowing it down a little more. Yeah. Maybe not so similar for both of them. Yeah. Actually, I think I like that previous combination a lot. This one, so I'm going to save that. Yeah. So it moves sometimes slow, sometimes fast. That's because we're nesting different signs. So this sign essentially will go into the other sign, which is why sometimes it's fast and sometimes slow. I'm going to save this one. Was not random, was animated. I'm going to duplicate again. So now, what are the things that we can change? So this is really, what I'm doing here is really the same way I work with like sketches, like the that I've been doing last year, since last year. Uh, sometimes it can be a very simple sketch, just change a number, move things around, and you will see a very interesting results. So that's for the animation. And let's actually add color. I can't wait to add color back to this. So it's not just black and white. To add color, let's try to have different color for each circle. So I'm going to add a fill inside the for loop, and the color is going to be based on the variable I, because I is a number that's going to change. And again, this is something that we did yesterday. I'm going to type somewhat quickly, 128 times 127. I'm a plus. I'm using this number because that gives us, so the smallest value we will get is 1. That would be 128 minus 127 if sign is equals to -1. The biggest value we'll get is 255. That's just because of that range. So I like to divide it by a number, so it's changes relatively slowly. We can give it a try. Now it's just from black to white. But once we add this to all three R, G, and B, make sure to delete the last comma. You only need a comma in between to separate the values. It's going to be the same because RGB is the same, but simply changing the numbers give you colorful gradients. And personally, I prefer to remove the stroke so you only see a color gradient. Well, then we can do that by typing no stroke. And now you see a color gradient. I'm going to save this, add another one, animated. Well, I think I'm going to add colorful to circles. Repeated colorful circles. And I'm going to create another one. Duplicate again. So now If you would like to have this those circles moving in a more circular fashion, we were doing Lisa Ju, but if we want this to be a little more circular, first I'm going to leave offset X and Y here for now, but I'm going to delete it inside of circle. Let's say 0.5 and 0.5. Let's see what happens here. So it's forming a circle. Actually, I think I'm going to do the divide by 20. Again, that's forming a circle. One thing we can do, actually, instead of just randomly picking a number, since we have 400, 400 essentially in this context is the number of circles we have. In order to control that, there's a couple of things we can do. One thing we can do is to create another variable to specify how many circles we want to have. So number of circles. Remember that variable name, you cannot have space in variable names. That's why I'm using this so-called camel case, where you capitalize each word, the first letter of each word, so it's easier, a little bit easier to read. Number of circles. Let's set it to 100, and then I'm going to use this variable in the for loop. So what happens here is the variable essentially is like something that can hold a value whenever you type something like let a variable equals to something else, then that variable become the same as a number. That's why I can replace the number 400 with this number of circles. So now I can easily adjust the number of circles here. So if I use 10, it's only going to draw 10 circles. It looks like a gradient, but it's actually formed by 10 circles, and then 100 circles. So that's an easy way you can adjust the number of circles that you have. And so the sine and cosine over here, now we have the number of circles. How do you make sure that it's always a perfect circle? Right now, you know, depending on the number of circles you have, sometimes it's less, sometimes more. What you can do is to divide I by number of circles. In this case, this whole thing is going to be always less than 1 because it starts from 0. The largest value is going to be is number of circles minus 1. So this is going to be somewhere between 0 and 1. And what we can do is then times multiply this by 2 pi. 2 pi essentially is 360 degree, and that's what makes a perfect circle in terms of when used inside of sine. So a sine all the way from 0 to 2 pi, that's a complete sine wave, and for cosine it's the same, and when you combine them, that's a perfect circle. So now even if you have 10 circles, it's going to form that perfect circle for you. So even if you only have 10 circles in total, it's going to use that limited number of circles to form a larger circle. So forming a circle. I'm just going to add this, make this a little bit bigger number. And I'm going to duplicate again. Now, if you want to animate this, we can add this offset. Let's see. Let's try add offset inside of sine and cosine and see what happens. I do want to add a plus sign. Offset. And now instead of such a small value, I like to be a little, yeah, make it a little bit bigger. Yeah. See how now it has, again, it's weird just working with 2D, because of the way the shape changes, it almost feels 3D. And rotating circle. And the part was 2 pi, the part of adding colors. Okay. So I just saw 2 requests in the chat. So one is a part about, by the way, don't be shy. Feel free to, sometimes I don't get to see the chat messages, so feel free to unmute yourself and remind me or ask any questions. So there are 2 questions. One is about the part about adding colors. So for adding colors, that's the same thing we did yesterday. So for color, we need 3 values at least. You can use 1 value for gray, but if you want to have colorful value, if you want to have different colors, you need at least 3 values. That's going to be R, G, and B. The first value here is the red value, and second part is green, and the third part is blue. And because by default in P5.js, the color values are anywhere between 0 to 255. That's why I'm doing this a little bit of math, so that the number is always somewhere between that range. And by adding cyan, it produces a color, it produces changes in color that's very gradual, which ultimately forms that gradient. It's actually also a great opportunity to show you a different way to do this. Instead, if you don't want to do this math yourself, there's also a very, very handy function called map. So for the R value, instead of this little bit of math, I can delete this and use map and -1, +1, and 0 to 255. I'll explain what's happening here. So this whole thing is a map function. And what map function does is to project or map one set of values to a different set of values, sort of proportionally. Because the output value for cyan is always between -1 to +1, we like to convert that to a number anywhere from 0 to 255. So we use a map function. The first argument is a cyan function, which is going to, so the cyan function will calculate the output, and then the output will be converted with a map. And the second part, which is 2 values, is a minimum value of the input, the minimum value before the conversion, and the maximum value before the conversion, so which is -1 +1. And then that's the end result. After conversion, what do you want the values to be? You want it to be 0 to 255, which is the range for the color. So this will do the same thing. I can repeat this process, and this time I'm going to increase. I'm going to use 3 different values. So even I made a mistake here, because when I copy and paste, I accidentally deleted an extra parenthesis. So for fill, it's opening here. You have to close it at the very end. So that's the colors we got. And I hope that explains the part about colors. And now, yeah, now the color changes like it's very similar color. That's because in total, we only have 100 number of circles. It's like making very small changes. So let's say if we add this value, it's going to be very colorful. And I actually I really like that subtle look with the 100 number of circles. I'll keep it like that. And then the second question is about the smooth repetition. Yes. Also the part about the 2 pi. I think instead of explaining that 2 pi, I'm going to show you what we can do here. And before that rotating circle, I'm going to create another one. Map, this one is about map function. I'm going to duplicate. So for 2 pi, we can also do 2 pi over here. So why did I add 2 pi? I'm going to use a whiteboard, again, that I created with P5 sketch to explain this. Run this, we have a whiteboard here. So if you think about a sign, for now, actually, for now, I'm going to use the regular or the Cartesian coordinate that we use in math. Usually when you think about sine, a sine wave looks like this. So the x coordinate or the horizontal coordinate, that represents the input. So this is x, oops, I don't think I can undo here. This is y, and what we are doing here is like sine x, sine x, y. Yeah, that was like a pretty basic whiteboard that I created, so I can't do undo here. So y equals to sine x. So the x essentially is input, which is x coordinate. So that means the input, input is 0, and over here, this is pi. This is pi here, and that's where 2 pi is. 2 pi. 2 pi right here. So that's a complete sine wave. So as an input, but what is pi? Pi is about 3.14. So that means as the input, this is input 1, input 2, and input 3, and 3.14. As the input increases, the output changes. So the corresponding output here, I think I do have different color. Output here, output, output, and output. So so by default, I think a lot of those input, if you simply use I as input, so the first part will be here. So the output is somewhere here. And then the second and third and maybe fourth about here and here. And because of that, from 0 to 6, from 0 to 6 or 0 to 7, you pretty much finish a complete sine wave. That means the value changes all the way from 0 to -1 to +1 and -1 and back to 0. So that's a very fast change. So after 6 numbers, you already make a complete sine wave. What we did by dividing this I by 50 is so that the changes, like you are essentially adding like 50 different changes inside. So every 50 changes, you are only changing it by 1. That means every some hundreds of changes, how fast you are completing a sine wave. And that's why the changes become much more gradual. You are basically slowing down the x, slowing down the changes of x. That way you are also slowing down the changes of y. I hope that helps explain this a little bit. But then now back to the 2 pi, because 2 pi is a complete change. now let's say because the color we have, this is not all the colors, we can do the 2 pi thing here as well. So 2 pi times I divided by number of circles. What's happening here is I divide by number of circles. I is small, start from 0 all the way to 99, and divide by number of circles. That essentially means this whole thing from 0 to number of circles, this sign goes all the way from 0 to 2 pi. I mean, close to 2 pi, because it's 99 divided by 100. So that's how it finished a complete sine wave, that it's going to finish all the colors. So let's see. If I copy and paste these here, it goes all the way from, I think from the top. Essentially, it will cover the whole range from 0 to 255. It's going to cover the entire range this way. And then if you and then you can add another value to slow it down. So if you want to slow it down, you can divide it by 3, divide by 2, and that also makes the colors to create interesting colors. I hope that explains it. So this is for color. Same thing for here. So actually, yeah, let me try to explain a little bit more about the circle part. I'll refresh this. Actually, I'll simply draw the sine wave. So sine wave looks like this, and cosine is somewhere. I'm not sure if I'm doing a good job with the cosine. Yeah, I'm not sure if I'm matching it perfectly. I'm probably not. But essentially, we are using sine as x and cosine as the y. Because of the way the sine wave and cosine wave works, that's simply the perfect combination of the perfect combination that forms that circle. Yeah. And where were we? So that's what we have. That's what we have here. I think there are more questions. Blend the 2 circles to have a smooth repetition, definitely. I'm going to save this one here. Actually, that's fine. So to blend the 2 circles, one simple way to blend is to change something called blend mode. If you go to p5gs.org.reference and search blend mode, there are different blend mode. If you work with Photoshop or any kind of similar image processing program, you might have encountered the blend mode. By default, blend mode is what's most intuitive to us, which means if you add new color, the new color will cover the previous color. But there are also other ways to combine colors. For instance, it will add the 2 colors together. And darkest, it will only show the darkest color between the 2 different colors. So there's different ways to blend the color. And that can create a smooth transition. So that, by the way, also include the background if you use blend mode. So let's try to change the blend mode to something else and see what happens. Let's say, for instance, if we use darkest, I think I need to, it needs to be all caps, darkest. Let's see what happens. So this actually starts to add up. That's because our background doesn't work anymore, because the whole reason why the background worked is because we are in the default blend mode, in which case it covers the entire thing. So in order for the background to work, we have to use the default blend mode for background, which is called blend. Yeah. So now I think that darkest, that's a little bit better than before. But how about add? I think I start to think that yeah. So there's essentially there are different blend mode that you can test out and see what works for you, and obviously that also going to change the color quite drastically. And darkest, I think I'll leave it as darkest. But I noticed, yeah, in this particular scenario, the darkest still does not give us a smooth transition because the first color and the last color does not match. So in order for us to match the color, one thing we can do is to use that 2 pi that we did earlier. So we already have 2 pi, where was it? The color. We were already using 2 pi. Okay. So in this case, for instance, this is a smooth transition because in order for it to be smooth, you want the RGB, like for each circle, you want the RGB to change. The changes also to be sort of a complete circle, change from a certain value back to that value. And to do that, you want to have that complete 2 pi here, which is what's happening right here. So from all the way from the in sine wave, all the way from 0, and it goes back to 0. But if you do want to have color, you can multiply this by a certain number. Let's say 3. So the reason why the multiply works is because when you multiply this complete sine wave by 2 within one circle, essentially it will complete 2 sine waves. So the color will change, finish a complete sort of full cycle of change twice. So when the 2 circles when the kind of 2 end meets, that's when it finished the complete cycle. So you can then play around with these numbers. But this will also have a pretty different look than what we had before, if this is what you are, if that's what you are trying to achieve. But this is one way, yeah. With coding, there's different people have different solutions. This is one way that you can do that. And yeah. And I hope that answers your question. I'm going to save this. So smooth transition, smooth color transition. Okay. And again, I'm going to duplicate. And let's see what's the next question. Perfect circle. In this part. The perfect circle 2 pi. Thank you. I hope this question about perfect circle, I hope that's also clear. If it's not clear, let me know and I can try to explain that again. For now, I'm going to continue. So that's one kind of animation that we can have. How else can we animate this? Let's go back to the circle part, the X and Y. And what we can do is now we can add a little Lisa Ju here just by changing one number, and then you see it animates differently. And since we can see the different circles almost at certain points, I like for a smoother change. So I'm going to increase the number of circles, And as you might have noticed, it starts to be a little bit choppier, so it's not as smooth. That's because the more circles we have, the more computing power it requires, and that might get slower at a certain point. So now it gets slightly slower. So maybe I'll lower the number to 500. Now it's much smoother. Yeah, I'm not sure if it gets across over Zoom, but for me, yeah, with 500, it's a lot smoother. So that's one other thing you need to consider as you work with sketches. You don't want just 10,000 circles or something that might slow things down. Yeah. Um, so rotating or animated, animated. And again, you can just simply change this number combinations to get different Lisa Drew pattern. So maybe times 3, like this, or even times 1.5, and see what happens. I'll leave it as this. Okay. So that's so much about the Lisa Drew and circles. Any questions so far? Any more questions before we move on to grid? Yep, all good. And please do remember to save your sketches. I try to duplicate every time I make changes. And so that I have a version of all this and later that I can share with you, so it's easier for it to follow along. So one great question from Susan: can you run multiple functions at the same time? Actually, what exactly do you mean by multiple functions? For instance, do you want to have like different patterns, for instance? If that's what you mean, you certainly can. And essentially, for instance, if you want like a different pattern on top, you can literally, I can just copy and paste. I should probably do a duplicate first. I'll duplicate, and literally just another for loop. And this time, maybe I'll lower the number a little bit so it's a little easier for the computer. Now it's exactly the same because it's same pattern layering on top of each other. But now if I make some small changes to numbers, you'll see it's two different patterns. Or maybe I'll make one of them a perfect circle. Yeah. So now you see there's both a circle and Lisa Drew. And to make it even clearer, what I can do is to maybe make one of them black and white. And so you can see there's two different patterns layering on top of each other. And that's one of the powerful things you can do about programming. You can keep adding. As long as your computer or your browser can handle it, you can add as much as you want. Yeah. So, forming multiple patterns. So now, if there's no more question, let's move on to the next section, which is to create a grid. To do that, I'm going to create a completely new sketch. So new sketch right here. And I'm going to call it workshop number 2 grid. And to do a grid, we need to do for loop sort of twice, both for the horizontal, the X, the columns, and then for rows. And what we can do here is to define the number of rows we want. So rows, so let's say 10 rows, and then columns, 10 columns. So I'm defining two variables with those numbers. So later we can easily change them. And once we know the rows and columns, number of rows and number of columns, then we can sort of calculate how big each sort of cell or each tile of the grid is. And let me open up the whiteboard again. So what we are trying to do here is that, so this is the P5JS coordinate, and I'm going to create a grid. Maybe I'll do 5 to 5, so just easier to draw. So this is what we want to do. So 5 to 5. And this is columns. So column 0, column 1, column 2, column 3, 4. And same thing vertically, 2, 3, 4. Back to here. How do we do that? So instead of 10, I'll put 5 for now. So now you want to have you want to know the width of the column, as well as the sort of, there's not enough room here. Maybe I'll use this one, as well as the height of each column. To calculate that, I'll say column width, or maybe tile width. That would be 400 divided by 5. However, if we type 400 by 5, that means when we change the number of rows or number of columns, we have to change both of them. And if we change the canvas size, we have to change everything. So that's very complicated. And when you have a complicated sketch, it's very complicated to keep track. So one very important variable that you can use, sort of a built-in variable from P5 we can use, is called width. So this magically gives you the size of the width. So if you change the width later, this will be updated as well. So you don't have to keep track of them. So width divided by, we already have a variable. So if we want the width divided by the number of columns. And tile height equals to height divided by the number of rows. And so now let's start writing a for loop. Instead of I, as I mentioned before, I can literally be anything that you decide to use. In this case, to make it seem easier to understand, I'm going to use let's see, I'm going to use row. The R stands for row, so let row equal to 0, and R smaller than rows, which is the number of rows, and R++. Okay, so that's a for loop. What happens is it starts from the 0th row, and as long as the row number is smaller than the total number of rows, it keeps increasing and goes to the next row. So that's the row. But for each row, you want to draw all the columns. So that's where we have a nested for loop, which is completely fine. Inside of that for loop, let's write for loop and let C equal to 0 and C smaller than columns, and C++. So as long as the C doesn't reach the number of columns, the total number of columns, C keep increasing and counting from 0 to the number of columns minus 1. Now we have both the R and C. Now we can use those two numbers to draw whatever shape we want. So instead of circle, I'm going to draw an ellipse. That's because with ellipse you have control with both width and height. Since we might have, we might need to do shapes that has different width and height. I'm going to use ellipse instead of circle. What's the position? For now, what I'm going to do is the tile width times column. That's the width. So this is tile width. So for the first one, the X position is over here. Maybe I'll use a different color. X position is here. The second column is going to be width times 1, width times 2, width times 3, and so on and so forth. So tile width times column number. And tile height times row number. I'm going to separate them into different lines so it's easier to read. What's the width? The width is exactly tile width, and the height is tile height. And this, is going to be a little bit offset. That's because we're using the top left corner as the center of the circle. So it's understandable there's offset. We're going to fix that in a second. Before we fix that, any questions? Anything you'd like to ask? All good? Great. So in order to fix that, essentially what you need is to move everything to the right a little bit and down a little bit. And how much we need to move? We simply need to move about half of the width and half of the height. So for the X coordinate plus tile width divided by 2, and for the Y coordinate, tile height divided by 2. And now we get a perfect grid with circles. Okay. And since we wrote everything based on variables, we didn't use a fixed number. Now it's very easy for us to adjust the number of circles we want. We can increase the number of rows, further increase the number of rows, 100, that's a little bit too much, 20 rows, and the number of columns, we can make it smaller, we can make it bigger, 20, so now they're all perfect circles. Yeah. So this grid actually gives us a really good foundation for some of the stuff we will be covering in the next couple of workshops, because we will be using a grid quite often. So if you have any question, ask it now and make sure you understand this part, because this is very important for the later workshops. All good with the grid? Yeah. And now you can, we've been drawing a lot of circles. Let's actually switch to rectangles, since we're working with a grid. Now, contrary to the circles, with rectangles, by default, the coordinate X and Y is referring to the top left corner of the shape, whereas circle, we are referring to the center of the circles. Actually, before I change, I like to just save grid of circles and duplicate grid of rectangles. Rect. Yeah. So Because the default behavior for rectangle is that the X and Y refers to the top left. So now we moved the top left a little bit to the right, a little bit to a little bit down. There are two ways we can fix this. One is to remove this offset, so that default behavior actually works. Another way, which is a new concept, a new function, is called a rect mode. Again, if we go to the reference, you can search rect mode. Rect mode modifies how you want to draw the rectangles and the squares. There are different ways. There are center, radius, corner, and corners. By default, it use corner, which, this mode, which means the first two parameters is X and Y of the top left corner, and the next two are the width and height. So there's different way you can draw different shapes. Or there's a one mode that's called corners. In that case, the first two parameters, you are specifying the top left, and then it doesn't have to be top left, and then the third and fourth parameters refer to essentially the opposite corner, one corner and the other corner. And since the value we had here is the center, the reason why I want to keep the center is that later when we want to do rotation and other things, it's good to have the center instead of the top left. So rect mode, we can use the rect mode center. With the rect mode center, we use the first two parameters as the center, the shape center, and the next two is the width and height. So that's perfect. So in order to fix this, you can simply add rect mode center, all cap, and that fixes this issue. So now it's a perfect grid. So with this grid, there are a few things we can do. One thing is to change color. The same way we change color with sine, cosine, we can add sine, cosine over here as well to change its color or its position or rotation. A lot of things that we can change here. Let's start with color. Right before you draw a rectangle, which is inside of both the columns and row for loop, we can add fill. This time we want to use both R and C. We can start with one of them. So for instance, if we use R, here we can use the map function to map the R value from what's the initial value for R. Initial value for R is start from 0 and it ends with the number of rows, the total number of rows. And what's the end result we want to get? Again, we want a value from 0 to 255. So now this is for row. That's why as the row goes down, the number start from 0 and goes all the way to 55. That's how we have a black to white gradient. Yeah. So it's mapping this R value from 0 to rows all the way to 0 to 55. Similarly, if you use the C all the way from 0 to columns, then that's from left to right. That's how you can create this gradient of grid. Now, similarly, we can repeat this process and do the same thing for both for all RGB, all three values. For now, it's the same, and we can make it a little bit different by changing this value. Again, divide this by 2, divide by 3, and then the color changes. But one issue we have here is that the number starts from all of the numbers start from 0. For row, for row, for column, it start from 0. That's why I start from black. If you want to make sure the whole thing is colorful, we can revert back to the sign. We can bring sign back. So instead of this, I'm actually going to delete this. Instead of directly using C, we want to put signs in here. So sign and C. Similarly, we can divide this by a certain number. And then we can either use that that equation, or we can use a map. So for map, we want to map this value to -1, from -1 to +1, to a number from 0 to 255. And I believe, this 100 is a little bit too much. That's because the total number of columns is 20, so divided by 100, the largest value is going to be is 0.2. That's a very small value. We can, if you want to make sure it's a complete cycle, we can do the similar things of C divided by columns times 2 pi. So that way, it starts from the light gray, goes all the way to the brightest. So this is where the sine function comes in. Start from gray. So sine start from the middle, which is gray, and goes all the way to the brightest, and then back to gray, and then to the darkest, and then back to gray. So this is essentially visualizing sine. If you do cosine, it's more symmetrical. Yeah. And now let's repeat this for sine, cosine, for RGB. I think I missed something. I need to copy the entire thing from map. And I missed a column. Yeah. So now we can simply make a little bit changes to each value to get a colorful gradient. Yeah. And this is just columns. You can do the exact same thing for rows. For instance, if you change, instead of C divided by columns, you can do row divided by rows. So over here, I used a shortcut. Whenever you're trying to select the exact same thing, the shortcut you can do is Command D. So Command D will select the next exact same occurrence. So for instance, if you're selecting 1 here, Command D will select the next one. So even though one of them is -1, the other one is +1, but because I'm only selecting 1, it's going to select all the ones. But R divided by rows is relatively unique. There's no other occurrence here, so I can do Command D. That selects all 3 rows at the same time, and then I can change them at the same time. So C divided by columns, and for now I want to keep the rows. And I'm also going to create another one with a colorful gradient and duplicate. Any questions? So with this, you can do both the row and columns. Then you can also combine them. You can combine the rows and columns by adding something inside of the cosine. So let's say, for instance, I will add column divided by column. So that's where the color changes becomes more diagonal. And then you can just make it bigger, make it smaller, and you will see how the change is different. So this gradient is at a diagonal. Yeah. And you can repeat this process, do this for the green and blue as well. Any questions? I'm going to duplicate this again. All good. So that's great. That's gradient and a grid and gradient. And then similarly, we can, we can adjust a lot of different things. We can, for instance, we can add sign. The possibility is really, really endless. You can add sign to the height, for instance. If I add sign to the height, and let's say I put r divided by rows and times 2 pi. It's very, I use 2 pi a lot. It's really just the same pattern. And if you want, so this is a complete cycle. If you want more, you can times 2, you see more. And then times 5, it's 5 cycles, and 1 or maybe 0.5 for half. A lot of things that you can do to create all different pattern. Yeah. Any questions? Yeah, just by changing that to cosine, that's a different, you see that different. Yeah. And also we can add animation here. Frame count is usually what I use to give animation, and that's a very fast animation. That's why we slow it down by dividing it. What is the number divided by 50? Now you see that smooth animation that changes the height of the rectangle. And we can simply copy and paste the height to width as well, and except I'm going to change this part to tau. Want to make sure it's matching. Yep. And then you can have different offsets of the animation. That's a little bit too fast, maybe slightly slower. This way the width and height changes at different speed, which should give it a little more interesting look. You can also, you can even just change sine to cosine, and yeah, and that's different. So there's really a ton of possibilities here. You can animate the colors, and yeah, animate the color, the rotation. We will do rotation in the next workshop. How do you decide the numbers to multiply or divide, or it's just trial and error? I would say as the more you do it, the better idea you have, like what exact number you are what exact number you do. Or if you're a mathematician, or if you're really good at math, you probably know exactly what you're doing. But otherwise, it can just be trial and error. Oftentimes, there are times that I really try to make sure that, oh, this is what I'm trying to achieve, but sometimes it's really just an accident. I accidentally enter a number that I did not want to have, and then I was like, wow, I didn't see this coming at all. So I think these are the moments that I really appreciate, and I really appreciate about coding, because there are a lot of happy accidents that doesn't happen as often with like a more traditional media, because in coding, if you just make a small changes, they can change the entire thing. and it might be something that you never really expect. Yeah, and again, I've been doing this for more than a year every day, so I've seen plenty of surprises that I really like. Yeah, so that's definitely one simple way that you can experiment. But also try to think more creatively, like instead of just changing numbers, for instance, maybe, we've changed the sizes, maybe also try thinking about changing, uh, to going with like a different direction. Yeah, it can be the sizes, or for some of stuff, maybe like the amount with like arc, like the amount of uh sort of the the angle, um or how big the arc is, like how much coverage of the entire circle the arc is. Like a lot, basically, yeah, there's a lot of different things that you can change and modify. Yeah. And also, I mean, I would say within each sort of type of sketch, there are all that different thing you can think of. But also another part of creativity comes in of as is that now I'm creating a grid. Maybe you can think of something else. I've shown how to create a grid, how to create like a sine wave and change it and animate it. But maybe you can think of some other pattern or some other way to put different colors together, or to put different shapes together, arrange it in a different way. And for instance, some of the sketches that I've shown, um, let me just quickly open it. Um, works, daily sketches. So, for instance, these ones, I really just started by repeating. So, the way we are repeating right now in that we did is a grid, but in this case, it's repeating more in like a spiral pattern. And I really just started with this. I didn't know where I will be getting to, but just by changing how close things are, changing different shapes, I was able to get, uh, you know, I was able to get like smooth gradients, all different kind of interesting patterns that I definitely did not expect. Yeah. So just think about how else you can use the skills that we've learned, that really helps, produce surprising results. Or in the first, there was a sketch. So for that particular, so there's a question about one of my sketches, some of my sketches like these. So these ones have some kind of it almost feel like it's drawn with a pencil, some kind of a scribble. I will not cover these exact type of, this is a little more complicated, so I'm not actually going to cover this, but I can show you how to create a curve. Yeah, we have about a little more time. Yeah, I can totally show you how to create a curve. And in the reference, uh, you can find curve. There are different ways to create curves. You can create curves just you can create a small amount of curve, or you can create like a long and complicated curve. The way I usually use to create a curve is use this thing called curve vertex. So vertex essentially refers to the control point for a complicated curve. It's like as if you're using the pen tool, or in Illustrator, you are controlling essentially each point, or in other words, each vertex, and then it will generate a curve based on certain algorithms. if you use curve vertex, this is a algorithm that's used. And then there's also Bezier curve. I'm not sure if I'm saying that correctly. Bezier curve, that's really popular. That's, again, you are specifying those vertexes, and based on those vertexes, there's this algorithm that generates a curve along those vertexes. And so let's try to do with the rest of the time. Let's try to create a curve. Duplicate. Not duplicate. I actually wanted to create a new one. So in order to create a curve, or any other kind of shapes that's based on vertices, you want to start with begin shape and end with end shape. So if I just type begin shape and end shape, nothing's going to happen. That's because you need to put curve you need to put vertexes inside. So before drawing any curve, let's draw some straight lines with vertex. So vertex 0, 0 is going to start from top left, and then vertex width and height, that's the bottom right. So I'm drawing one continuous line from top left to bottom right. So that's what this does. If I wanted to stop in the middle, I can draw something like this. So start from 0, 0, ends at the center point. The vertex, you can keep adding vertices. I'll, instead of this, I'll just, to make it a little easier to understand, I'll just use numbers, so 200, 300, 400, and maybe I'll go back to 400, 200. And yeah, right now I'm just really entering random numbers. Yeah. So essentially you can just use different, all the points that you want to, the exact point that you are, you like to use as for the curve. These are the shape, these are the positions that you can choose. Then there's option for end shape. There's option called close. That closes the shape. I'll make the stroke weight a little bit thicker so it's easier to see. So without close, it starts from the starting point and ends at any point. But if you add close, it will automatically add extra line that combine the very first point or the very first vertex to the very last vertex. And for vertex, you can also change the fill color, red, yeah, or light gray fill color. That's kind of hard to see. Maybe dark gray. Yeah, and so for vertices, there's actually a lot of interesting thing that you can do. So begin shape. For begin shape, there's a few options that you can choose. By default, you are drawing lines. But there's also option of drawing triangles or points or quad. I'll just demonstrate triangle. What would the triangle do? So if you add triangles inside of begin shape, it's going to draw multiple triangles. But that's only if you have a lot, yeah. So if you have a lot of vertices, based on your vertices, it's going to try to draw multiple triangles. And there's also triangle strip. So the whole thing will be connected with different triangles. So this almost has like a origami look, depending on what you want to do. Or I believe one option is point, yeah, points that just give you all the points that you selected. But in a way that almost defeats the purpose of vertices, because you can simply use point to draw that. But in certain scenarios, that can be very useful. No, I didn't mean to delete begin shape. So I'll remove this. And now, if you like to draw a curve, the only thing you need to do is to, instead of vertex, the only thing you need to do to change all this vertex, I'm going to use select vertex and do Command D select all vertices, and I want to change vertex to curve vertex. Now you have a curve. And then you can use this curve to create any kind of things. I use the curve to create a scribble looking pattern. And if you don't like the fill color, you can also turn off fill by typing no fill. Yeah, this gives you just the pattern. One thing you do need to note is when you are using curve vertex, the first and last vertex, notice how there are 4 points that's drawn over here, but the vertex, there are actually 6 vertices. So the first and last vertex, first and last vertices are used to control the angle, the shape of the curve. For the detail, you should look up this name where it explains exactly how, it's essentially some mathematician that come up with those algorithms. If you are interested in that, you can Google it and find exactly how it works. But the first one is the last one is used to control the curve. That's why when I use vertices, if I go back, when I use vertices, you see there's a point on top left and a point here. However, when I switch to curve vertices, you do not see the first and last one, because that's sort of only used to change the angle. So for instance, if I change the first one to something else, the curve is changed, but the first point still doesn't show up. That is used to change the angle. Yeah. In this example, for instance, it doesn't want any particular angle, so you can also use the exact same number for the first and second vertex. That's also fine. So I can repeat this, and then that will show up. So that's curve workshop number 2, extra curve vertex. Any other questions? So if there are no other questions, let's try to get back to the save GIF. And I'm going to open one of the old previous one. I think I don't need one. I'm going to delete this. Okay. Animate it. Give this a new name and duplicate. Now let's try the save GIF. Again, go to the reference page. I'm simply going to copy, save GIF. So that's a simple way that you can save and share your sketch. Over here, you can copy all this part and paste it near the end of the sketch outside draw. What it does is key pressed is only triggered if a key on your keyboard is pressed, and if this key is S, if you press the S key, your sketch will be saved with the file name my sketch, and it will record for 5 seconds. So let's test this out. So this is sort of, then you can adjust if you want 10 seconds or 1 second and whatnot. So run this, and please make sure to click the preview before you press S, because if you press S inside of the code editor, you are simply typing S. So you have to activate preview first and then press S. You can see indication, saving frame, and then later it's rendering frames. And once it's saved, it's going to be saved to my, it's right here. And let's see if I can open, yeah, it doesn't open in, yeah, it doesn't automatically open in this Firefox in my browser. Let's see if I can open it here. Yeah. So essentially, yeah, it was successfully saved the GIF to my hard drive, and that's how you can save GIFs. And I just noticed one other question. Could you complete a shape? Could a complete shape of an origami shape be coded here? Whenever I see questions about can something be done, the easiest answer is yes, it definitely can. Like with coding, you can pretty much do everything because when you are the coder, you are the person that really has all the power to make all the changes and do anything that you want. And the possibility is really endless. You can do a lot of things here. So if you want a complete shape of an origami, you can definitely do that in here. However, that might means that you need to spend a little more time learning a little more before you before you are able to do that. Um, but you can totally try that triangle strip, for instance, and play with it and see how that works out. Yeah. So basically, the answer is yes, you can, but yeah, it might take a little bit of time. And I hope with this workshop, people are really all of you are really inspired to go beyond the workshop because it is a 5-day workshop. It is a lot of time. However, the workshop I really hope to get you started with creative coding with p5.js so that now with all the things that you've learned in this workshop, you are able to go beyond what we've covered in the workshop with all the references or all the online resources. I keep bringing this up, but when I was a kid, I really wanted to learn something like this, but I did not have resources for that. If someone showed me how to the basics, then I think there was basically that would be very exciting for me to really learn beyond the basics. So I hope that's what this workshop can do, and I hope you all enjoyed the workshop. So thank you again to all of you for attending this second workshop. And I'll wait for a couple more minutes for questions. So if you have any question, feel free to send it in chat or let me know. And one of the question is, will I share today's file? Yes, I will. I shared a link to P5JS collection, which is a collection of sketches for this workshop. I will add the new sketches in that collection, so you can use the same link. But once the recording is uploaded, I will also send another email to remind everybody about the video and the code sketches. Thank you all. I see a lot of thank yous. I'd like to thank you all as well. So if there's no questions, this is it. Again, thank you all, and I'm really looking forward to see you tomorrow.